All right, fourth grade, happy e-learning day. You get to be at home doing your math and your reading in your PJs, maybe sitting at the table having some breakfast. Lucky, I'm in a meeting. So, to make it pretty basic today, what you're going to do in math, we're going to start with the workbook pages I sent home, page 124 to 126. We pulled those out Friday out of our pretty workbook. For those of you who might have been absent Friday, I will have screenshots of it. You would need to look at the problems or follow along with this video and just work out on paper. Pause and draw what you need to. Okay, so that everyone comes back with work, not just answers, but work. All your problems need to be annotated so that you're really focusing in on the question. So you can choose at this time to go ahead and pause this video and work through problem number 1 on your own, and then give it a shot, and then turn your video back on and see if you got it right. If you are looking at number 1 and you're a little bit, you can't remember the definitions for factor or multiple, then go ahead and just work along with me, and then you'll have the correct answer. And you can do that throughout this entire video. I challenge you to pause the video and try each problem before I work it out, okay? Because this is a unit that we just finished, and we want to make sure that we're feeling solid about the vocabulary and how we're being asked to solve some of these things, okay? So here we go, pencils ready. We got workbook page 124 to 126 ready to go. I'm going to annotate. I've been having some trouble with my Apple Pencil, so I hope that this goes well. Which number is both a factor of 60 and a multiple of 6? So we have two things going on here. Your factors are your math facts. So that's going to be of 60. So we're going to make a list of factors for 60. And then a multiple, multiples go higher, and that's our skip counting. And then we're going to skip count by 6s. So I'm going to do that first because I think that's easier. So we're going to do the multiples of 6. Do it with me. 6, 12, 18, 24, 30. And I notice that A, B, C, and D, nothing is bigger than 30, so I can stop there. So when I do my factor pairs, remember we're going to make it like a tree. We start with 1. We're going to go in order. Does 1 work? Yes, always. 1 times 60. Does 2 work? Why does 2 work? Because it's an even number. Half of 60 is 30. Then we ask ourselves if 3 works. If I count by 3s, do I land on 60? And I do. There's a divisibility rule we're going to learn in about a month that will be, you can calculate it in your head pretty quickly. But basically, if I take 6 plus 0 and get 6, 3 divides into 6, which means 3 would divide into 60. And that's an actual proven rule that we're going to memorize. We just haven't gotten there yet. So 3 times 20 makes 60. Does 4 work? Nope. Does it? What do you guys think? What if I don't know? What should I do? Yeah, I should divide it. So go ahead and divide it. We're going to do the partial quotients method. I'm going to do, that's a G, sorry. 4 groups of 10. It's going to be 40. It's going to leave me 20. Ooh, 4 groups of 5. So I could have skip counted by 4s, but I could also check it really quickly with my division. And yeah, 4 times 15 is a factor pair. Those are the kinds we have to check because those are the kind of things they'll throw at us in iLearn, the ones that have those tricky ones we don't know our math facts for. What about 5? Yep, because it ends in a 0. So 5 times 12. And does 6 work? Yes, 6 times 10. Those are the factors of 60. 7 doesn't work, 8 doesn't work, 9 doesn't work, and then I'm back to 10 and increasing, so I am done. So it wants to know both. I hope you annotated both. Look for 10. Is 10 in both lists? Nope. It's in one, but not the other. Is 12 in both lists? There's a 12. Yep. Looks like that's the winner. There's an 18 here, but not an 18 there. So nope. I do go ahead and check everything to make sure I didn't make any mistakes. We've talked about this. We know we don't find one and stop. It's a way to check our progress. So yes, but not in both lists. Okay, so a number that is both a factor of 60 and a multiple of 6 is going to be 12. Make sure you come with work. Just an answer is not going to get the job done. You'll have to redo it. Number 2, get ready to annotate. Pause if you need to so you can try it first. There are 12 zebras at a zoo. There are 4 times, I'm going to put my 4 times by that, as many zebras as lions. How many lions are at the zoo? How many lions? So we don't know how many lions. Okay. We know there's 4 times as many zebras. So let me think of an algebraic equation I can write. 4 times, let's use Z for zebras. I make my Z's with a little line through them so they don't look like a 2. Remember that what we talked about as we start to write this algebraically and we use variables, that we're going to put the number beside the letter with no space. And that means, this means 4 times whatever is going to be Z. So there's 4 times as many zebras as lions at the zoo. I feel like I'm starting this problem wrong. I'm pausing awkwardly because I feel like I'm getting, because if I do this equals 12, yeah, I'm doing it right. I'm sorry. I'm having a brain cramp this morning. How are you doing at home in the comfiness, right? So this is asking 4 times, this is what you did when you were little in 3rd grade and 2nd grade, 4 times what equals 12. And that's what basically we're trying to figure out. So we have it set up right. It's an equation because we put in an equal sign. We do know that there are 12 zebras at the zoo. I maybe should have put this variable as an L for lions, because that's really what I don't know, is how many lions. So I think that's what threw me, as I set up my variable wrong. So that's one of those things, as when you're doing math, you start a problem and you get partway through it and you're like, wait a minute, something doesn't feel right, it doesn't seem right, okay? So let's go ahead, and we know that 4 times 3 is 12. So let's go back and think about that. I think it's going to be A. It says how many lions. So let's work it backwards. If there are actually 3 lions like we think, and there's 4 times as many zebras, and we know that there are 12 zebras, and we worked it the opposite direction and went back to our thinking, yes, we did do it correctly. Mr. Sharp kind of started off a little sketchy this morning, but that happens sometimes. Okay, so we're going on to number 3. I got to switch pictures here. I was having trouble this morning with my recordings and my pictures, so I had to get some different screenshots. So we're on number 3. Go ahead and pause and annotate. Come back to me when you're ready. All right, welcome back. Tell whether the expression, all of these are expressions because they have no equal sign. Tell whether the expression could be used to find 4 times 7. Choose yes or no. First thing I'm going to do, I know there's multiple ways to do this, but the very first thing I always do is I go ahead and solve it. It makes me feel better. I know what I'm trying to get. So I could simply go through and solve each one of these, and then I'm yes or no. That's one method. The other thing I could do is look at the parts. So let's look at the parts first and then solve. So I have 4 distributed twice inside my parentheses. So this is saying 4 times. And remember, when we did this, the second number in the quantities should, if it works and you put it together, should add back to the number you're trying to use in the second factor. So if I break apart 7, does 3 and 4 broken apart make 7? The answer to that is yes. Did I multiply each of the parts of 7 by 4? Yes. That means this works. Now, that's one method. The other thing I can do is solve my parentheses. And we learned that you solve parentheses first. They're most important in the level of math we're working. 4 groups of 3 is 12. We're going to add last. And 4 groups of 4 is 16. And 12 plus 16 equals 28. That's the method I like to already have the product. Next one. So I'm going to look at my parts. This algebraically says 4 times what's inside, okay, inside your quantity. Does my quantity, my parentheses, add up to the 7? And the answer to that is yes. So this one should also work. That's one method. Then I could just simply go ahead and solve it. Parentheses first. I'm going to get 7, and this ends up being 4 times 7. That's the order of operations. And we know that that works. They were the same factors. Okay, this one is a little different because they threw a subtraction at you. So instead of adding the 2 parts together like we did in A, now we're going to subtract the 2 parts. You'll notice they distributed the 4, so that's a good move. That is correct. So now I'm looking at 9 minus 3. Does 9 minus 3 equal 7? The answer to that is no. So if I'm not adding up or getting a difference, in this case, of 7, it doesn't matter that they're multiplying by 4 because they're not using the other factor of 7. So this is a no. That's one method. I do the quantities, and I get 36 minus 12, okay? And that's going to be, what, 24? So that proves that it was a no. Again, why I like to solve it first. Last one, looking at the parts. Yes, they're multiplying by 4. Does 8 minus 2 equal 7? No. So that can't be a way to break apart and solve 7. So this is going to be a no. If I solve it, because you know we like to do it both ways to make sure we're right, parentheses first, 6, 4 times 6 equals, got another 24. Okay? So make sure you have some kind of markings on here for me. Showing work, showing your thinking, which method did you use? Not just a yes or no. You know that's not the way we do things. Moving right along on this morning. I told you I was in a meeting, right? You guys are lucky to be at home. All right, we're going to edit this one. This one's a little bit more of a story problem. It make me hungry. A little bit cut off, but it says Tony needs to buy hot dogs and hot dog buns. So hot dogs and means I'm going to add something maybe. Hot dog buns for his cookout. He decides to get 24 of each. 24 of each. Sounds like we might be multiplying, but sometimes each means divide. We have to think it through. A package, okay, so a whole package of 8 hot dogs is $5. A package of, let's make the buns more like a square, costs $2. Meat's always more expensive than bread. Okay. There are 8 in here. There are 2 in there. I might just put an HD for hot dogs and a B for buns by my picture. Okay. Let me clean that one picture up. Are you guys making pictures? Models? We're mathematicians. We make models, not pictures. So we've got $2 here. So we took my words, created a model because you understand those easier. All right, so we're going to complete the table to find out how much he'll spend for hot dogs and buns. Okay. So he's deciding to get 24 of each. So I think we have to come back to this 24 of each. 20, I'm going to put that down here. 24 of each. I like it to be where I can see it and think it through. So we're going to start with hot dogs. We're going to come up to our model for hot dogs. There are 8 in a package. Okay, so we're going to have 8, 16, 24. So that's going to be 3 packages of hot dogs. Each package costs $5. So that's going to be $15. Okay. I put the dollar sign. I'm actually going to erase it because they have it in the heading, so I don't need it because the heading takes care of the labeling for the whole column. Buns. So I need 24 buns, and buns come 6 buns. Okay, so this should be a 6. I don't know if I erased it or wrote it wrong, but that should be a 6. 6 buns in a package. Okay, so 6, 12, 18, 24. And then how much does each package of buns cost? So first of all, that's 4 packages. 2, 4, 6, 8. Now that's not how many buns, that's the cost of each buns. So 4 times 2 is 8. And we had 3 times 5 was 15. So then the total cost, total is an addition word, so we're going to add here, and we're going to get $23. Again, the dollar sign's up here, so I don't need to repeat it. I want to see some modeling, annotating, show your thinking. Work as hard as I'm working. We're going to head to number 5. Give it a shot. Pause. Each value for y is 2 less. Can't see it when I let go of it. I don't think I'm going to be able to annotate this one, gang, because of the way my... Where'd my picture go? There it is. I can't... Oh, there it goes. There we go. So each value for y is 2 less, so minus 2, than 4 times x. So 4 times x. So to get y, that means I'm going to take 4 times whatever x is, and then 2 less, I'll subtract 2. So let's try that on the first one. If we put 1 in, 4 times 1 minus 2. We're going to multiply first. So that'd be 4 minus 2 is 2. Perfect. We wrote it correctly. Let's try the next one. 4 times, and again, we're going to our expression. We wrote it. That's our rule based on our words. So 4 times 2 minus 2. 8 minus 2, 6. Next one. 4 times, if x is 3, 4 times 3 minus 2, because the 2 less at the end. Multiplication is more important than subtraction. So 12 minus 2, 10. 4 times 4 this time, 16 minus 2, 14. And the last one. Write the expression. Everyone should have the expressions written. Oops. I switched them. Does that matter? I don't like it switched because I like to keep it in the order of my words. But that's the commutative property, and that actually does not, it wouldn't be wrong. Still going to be 20 minus 2 is 18. We filled out our in and out table. Later, it's going to be called a function table. And the rule pattern was 4 times x minus 2. All right, number 6. One page done. Got us a story problem. There are 1,024 people watching a musical at a theater. The theater has 8 sections of seats. The same number of people are sitting in each section. Okay? So, we talked about each being a multiplication and a division word. What I need to think about here is, am I trying to find a total number of people, or am I splitting up the number of people? Okay? And because I have the total number of people, I'm trying to fit them into a smaller number. That is a division problem. And I'll tell you, as I've gone through school, there has been times I couldn't tell which I needed to do, so I did it both ways, and then I thought through the problem of what made more sense. Okay? So I have 1,024 people. We're going to do the partial quotients model, and we're dividing into 8 sections. Put the groups over here. And I'm going to start with 8 groups of 100. Yeah, that'll work. 8 groups of 100 is 800. Nice zeros, easy to subtract. Don't forget to regroup. Now, 8 times what? What do you want to try here? 8 times 20. Let's try 8 times 20. What's 8 times 20 going to be? It's going to be 16, so 160. That works. Subtract. 64. And we know that 8 groups of 8 is 64. So everybody gets a seat because there is no remainder. So that is going to give us 128 people in each section. Okay? Explain how you found the answer to part A. Explain. I want a sentence here. Okay? We're going to say, we're going to restate this. In part A, oops, I should make that capital. In part A, I divided 1,024 by the 8 sections to learn there are 128 people per is another word for each section. I have a capital. I've restated the question, and I've put in my solution. Okay? All right, number 7, almost done for the video piece. All right, Josh solved a multiplication problem using 2 different methods. he made a mistake in either A or B. Ooh, so one of them's wrong. Okay, so what does he have here? He has the area model. Let's look at that one first because I like the model. It's easier to look at. So we're looking at B first. 10 and 5, yep. 30 and 8, yep. 10 times 30, 300, yep. 10 times 8, 80, yep. 5 times 30, 150, yep. 5 times 8, 40, yep. And then we have all the same numbers. That should be right. When I look over here, and he did this method, okay, he's got a 10 and an 8, so yes. He's got a 5 and an 8, yes. He's got a 10 and a 3. That's not a 3, that is a 30. So that is wrong. And then he's got a 5 and a 3, but this should be a 30. So he's ignoring the fact that that's in the tens place. So that's where Josh's mistake is at. Identify the method, so I have to say the method where Josh made a mistake and explain what he should do to correct it. Josh made his mistake in method A. Okay, so I did that first part. Where's his mistake? What should he do to correct it? I'm going to go ahead and make that a simple sentence. Josh made his mistake in method A. To correct, so I'm going to restate, use my writing skills. To correct his mistake, try to avoid using things like it when you're doing detailed descriptions. To correct his mistake, he needs to multiply 10 and 5 by 30. Okay, I ran out of room. I should also say that he's going to re-add as well. All right, so that's the end of the main part. And then you have, I've got to go get you guys from music. I'm actually recording this on Thursday. So specials are almost over. I've got to go. All right, so let me go one more thing. Turn the page. You have a performance task. I'm going to read it. You're going to annotate. Melanie is in charge of setting up the chairs for tonight's student jazz concert. She has 96 chairs to arrange into rows in one of the classrooms. Each row needs to have an equal number of chairs. I hope you're annotating, gang. Okay, so 96 chairs to arrange in rows. That's her total. That's all the chairs she has. Each row needs to have an equal amount, so you can't have 7 in one and 3 in another. Find at least 6 different ways Melanie could arrange the chairs. 6 different ways. Choose one of the arrangements. So this is one step. 6 different ways. Choose one of the arrangements and explain why that does not make sense. So it might work mathematically, but does it work inside a concert? Because some things work mathematically, but they don't make sense in real life because you don't have enough space, it's too crowded, so you have to think it through. Then choose, step 3, the arrangement that you think would work best. So you're making a choice, and you're going to draw a picture of it. It shows how the chairs should be set up and explain why you chose that plan. So I'm going to want some factor pairs for step 1. I'm going to need a sentence for step 2. I'm going to need a sentence or 2 for step 3. And then I'm going to need a picture and 1 to 2 sentences for step 4. So I'm going to give you a hint. What I would do is I would write down 96. I'm going to start through my factor pairs. I have 96 chairs. I can put 96 chairs in one row. Or and I say it backwards, 96 chairs in one row. What if I have 2 rows? How many chairs? Does 3 rows work? See where I'm going with that? Finish up that task, pause, and then there are some answers past this for you to check everything out, and there's a spot where you can screenshot and make sure that you have what you need. Okay, so when you're done with all of this, and you've checked everything, and you have the workbook pages done, then what I need you to do and finish up is you're going to spend 10 minutes. There's the answer key. Take a screenshot of that. There's the answer key for the first page, the answer key for the second page. Make sure you got your work right. And then the answer key for the rubric. This is if you had the best possible answer, you would get 4 total points, okay? So when you're done, then I want you to be on 10 minutes of IReady, My Path, and 5 minutes of fact practice. And then your math is done, and make sure your reading's done, and have a great day. Bring this all back with you tomorrow, and I will see you on Tuesday.